Hi guys, in this video we will discuss about the D operator method when the right hand side of the second order differential equation is of the form that r is equal to e to the power mx into v, where v is either a trigonometric function or v is an algebraic function. So here I will take here two problems, that when v is the trigonometric function and when v is an algebraic function. So now let us discuss about that how can we solve the second order differential equation, or how can we find the particular integral when the right hand side of a second order differential equation is of the form e to the power mx into v, where m is a real number and v is either a trigonometric function or v is an algebraic function. So here we consider the function d2y dx2 minus 4 dy dx plus 4y is equal to e to the power 2x sin x. So first of all we have to find the complementary function, and you already know that how to find the complementary function by making this equation homogeneous. That means we have to, for finding the complementary function, we have to make right hand side is equal to 0. So here we will take y is equal to a e to the power mx is the trial solution. Then we will use dy dx, we will find dy dx and d2y dx2 from here. So we will get this result, that m a e to the power mx plus m and d2y dx2 m square a e to the power mx. So here the auxiliary equation is on the form m square minus 4m plus 4 is equal to 0. And we will get m is equal to 2 and 2. So here roots are real and distinct. So now the complementary function is on the form y is equal to c1 plus c2x into e to the power 2x, where c1 and c2 are arbitrary constant. So now the question is that how can we find the particular integral? Here the particular integral 1 by d square minus 4d plus 4 of into r, where r is equal to e to the power 2x sin x. So here we will find that we will find the pi when r is equal to e to the power mx into v. Then we will find the particular integral like this, that 1 by f of d plus m into v e to the power mx divided by f of d plus m into v. So here we can write from here that 1 by d square minus 4d plus 4 e to the power 2x sin x is equal to, we can write 1 by d minus 2 square e to the power 2x sin x. And now here we will put the form f of d plus m, and here m is equal to 2. So here if we put d plus 2, so we get e to the power 2x by d plus 2 minus 2 whole square sin x, and finally we get e to the power 2x by d square sin x. And as you know that 1 by d to the power p f of x means we have to integrate the function f of x p times. We have to integrate the function f of x p times. So here we have to integrate sin x 2 times. So here we get e to the power 2x by d integration sin x dx. That means we get e to the power 2x by d minus cos x. And now again we have to integrate this, that is e to the power 2x integration of minus cos x dx. So here we will get minus e to the power 2x sin x. So now the required solution, that is y is equal to cf plus pi, that is the complementary function plus particular integral. So that is y is equal to c1 plus c2x e to the power 2x minus e to the power 2x sin x, where c1 and c2 are arbitrary constant. So now I will go to the next one, that is when the v is an algebraic function. So now go to the next part. So here I will take the problem as d2y dx2 minus 4 dy dx minus 5y is equal to x e to the power minus x. So here first you have to find the complementary function by using auxiliary equation. This is very simple. Take y is equal to a to the power mx, then find dy dx and d2y dx2, then find the auxiliary equation by using this. So we get the auxiliary equation is m square minus 4m minus 5 is equal to 0. So from here we will get m is equal to 5 and minus 1. So the roots are real and distinct. So the complementary function is y is equal to c1 e to the power 5x plus c2 e to the power minus x. So how can we find the particular integral here? Here also we will put 1 by d square minus 40 minus 5 x e to the power minus x, and also here we will put that 1 by f of d plus m v e to the power mx by f of d plus mv. And see here m is equal to minus 1, so here we put d minus 1 whole square minus 4d minus 1 minus 5x e to the power minus x. So from here if we simplify, we will get e to the power minus x divided by d square minus 6dx. So now to solve this one, we take common from here minus 6d. So what we get? 1 minus d by 6x. So from here we can write that minus e to the power minus x by minus 6d, 1 minus d by 6 whole inverse x. And from the expansion of 1 minus x whole inverse is equal to 1 plus x square, we will find that 1 plus d by 6 plus d square by 36 plus dot dot of x. So from here we will get minus e to the power minus x by 6d x plus d by 6, that means d dx of, here d stands for d dx, d square stands for d2 dx2, and so on. So we get 1 by 6, and from second order it will be 0, so we will get minus e to the power minus x by 6d x plus 1 by 6, and here d means we have to integrate these two terms one time. So here we will get minus e to the power minus x by 6 integration x dx plus 1 by 6 integration dx, and if we simplify we will get minus e to the power minus x by 6 into x square by 2 plus x by 6, and here 1 by d, that means we have to integrate this one time by the rule that 1 by d to the power p f of x, that means we have to integrate this function p times, and here p is equal to 1, so we have to integrate one time. So the required solution is of the form, so the required solution is y is equal to c1 e to the power 5x plus c2 e to the power minus x minus e to the power minus x by 6 x square by 2 plus x by 6. I hope you understand. So thank you.